All right. So not last week, 2 weeks ago, Nico wrapped up his lesson on the UI. I believe there was more he wanted to go over, but he's unable to attend tonight. So we're gonna jump to the next lesson, which is Express. So we've been working on our UIs and everything, which is cool. But then on the back end, on the server side, there's code that lives there as well that we'd want to get into so that your UIs connect to something and they make stuff happen. So I posted a link in the advanced web channel for Postman, which we're going to make a little bit of use of. It's not required per se, but it'll make this a lot easier because all the endpoints that we're going to create in our new server, Express server, we can test using Postman manually. So let me know if anybody needs time to get Postman spun up, downloaded, all that fun stuff. But in the meantime, I'll just go over some things that we should know prior to spinning up an Express server. So what we'll be making are called endpoints in the server, and endpoints are routes to the server that do whatever it is we're going to do. And there are different types of requests that we can make over what's called HTTP, Hypertext Transfer Protocol. So you're probably familiar with, of course it doesn't show it. There we go. There's HTTP and HTTPS. S is just the secure version that encrypts it and creates a tunnel. Most websites nowadays are HTTPS. But the Express server we're making, just for simplicity, is going to be regular HTTP. And not almost, every single website is hosted on hypertext, is what I'm going to say, because HTTPS is kind of hard for me to say. But hypertext is the foundation, not the foundation, but it's close to the foundation of the internet as we know it. Anytime you visit a website, you are invoking this protocol, specifically a GET request. When you're filling out a form, you're probably making a POST request. When you're searching, you're probably, well, that's probably another GET, but you get the picture. And most websites, when you visit them through their URL, you're making a GET request. So there are several different types of requests that HTTP supports. The most common are these first few up to delete. The rest of them I don't really care about. I've never used them personally, but you've all used GET just by visiting a website URL. POST is creating a new resource on the server, whatever that means. For our purposes, when we start working with databases, that's going to be what we'll use to create a new listing in the database. Put is updating a pre-existing resource. And patch is pretty much the same as put, except patch, put will replace a resource with whatever resource you give it. So if you have a database full of, usernames and emails and just those two items, when you make a put request, the idea is you are sending a new object with a name and an email that will replace the old one that's already on the server. It's a full replacement. Whereas patch, let's say I just want to update the email on a certain listing, but not the name. That's what it would do. It would just replace the email. And really, I see most of the time that people just rely on get, post, and put. Delete is self-explanatory. That tells the server that you want to delete something. With all that being said, however, Express doesn't care which of these you use. You could set up a get endpoint to delete something. Should you? No, but you can. Express doesn't really care. So we have to keep these rules in mind for ourselves when we're creating our endpoints. And again, I see most of the time people who write servers rely on get and post because at least with Express, there's no functional difference between these at all. You can send a body with get, which normally you don't do. Post, it can have a URL encoded set of variables, which, well, post has that anyway, but post usually you send a whole body, and we'll get into what that means once we start writing our projects. So yeah, this is Postman, and the way it works, it's pretty simple. I'm making a GET request now to Google. This is exactly what you do when you type in Google in a web browser like Chrome. Except Postman doesn't show you the pretty Google page. It shows you the actual source code of the page. So we're going to create our new, let me get out of this. We're going to create our new project, and it's just going to be an NPM init. There's no NPX script like there is with spinning up a React app. It's a lot more lightweight. In fact, Express prides itself on being lightweight, and it's going to be quicker to actually code. But there are some differences in the code we're going to write for Express versus for React. In particular, we won't have the import and export keywords. While we can set the project up to have those keywords, it's more effort than it's worth. So you'll just have to get used to using the require syntax instead of import. So I'm going to make a new directory, Express demo. CD into Express demo, and we'll use npm init. And I'll just do a -y to answer all the questions. And going back to week 1, this creates our package JSON. Now we're of course going to need Express, so npm I Express. And while that's downloading, I will go to the Express page. So it's known as Express.js, and it is a fast, unopinionated, minimalist web framework for Node.js. So unopinionated, that's where it comes in, where it doesn't care what HTTP protocol you use, get, post, put, whatever. Doesn't care what you do with it. It's minimalist, so there's really very little setup, and it's pretty fast. In fact, it's faster than other technologies in other languages like Java Spring, I believe. I read a benchmark that Express actually is faster than that, which is kind of cool because it's JavaScript. But this documentation will tell you everything you need to know about Express and go into some other topics like middleware functions, which we'll talk about, and what the next function does that we'll see in use, among other things. But there's really not a whole lot to learn. Express is pretty, just post this. Express is pretty lightweight. It's easy to get started. There are some things that can be a little confusing about it, like how routing can work. But yeah, you'll see how simple it is once we dive in. So I've got Express downloaded. I'll open this in code. Was my other project. So first thing, we're going to create a server.js. And we're also going to create app.js. So the reason that these are going to be in 2 different folders, or 2 different files rather, is app.js is where we're going to define all of the top level routes and actually create our Express server. And server.js is actually going to have it listen on a certain port. And we have them separated for a reason. It's mostly for testing purposes, which we won't really get into today, I think, but it's for unit testing. So in unit tests using Supertest, we can spin up a whole Express web server, call endpoints on it, but we'll never actually listen on a port because it won't run server.js. But we're going to start an app. So to create or instantiate our new web server, const app equals Express. And I forgot to import Express. Const Express equals require Express. So like I said, with these projects, we don't have the ability to import Express. And the reason for that is under the hood with our React UIs, there's something called Babel. Babel is a transpiler that takes newer JavaScript code and transpiles it into older JavaScript code that Node or Chrome can actually read. Because the big players who write the interpreters, such as SpiderMonkey for Mozilla and the V8 engine for Chrome and for Node. They haven't caught up with all the newest features, including the import syntax. So if I were to write import Express from Express here, it's not yelling at me right now, but in runtime, this may not work. Although this could be different from Node 16, I'm not sure, but for now, we're just going to use const equals require syntax in order to bring Express in. And then we're going to invoke the Express function because that's what this is. And this creates our new app. And we're going to set up our first route, app.get. So we have those different HTTP protocols, such as get and post and whatnot. So app.get creates a get endpoint, app.post creates a post, et cetera, et cetera. And there's one of these functions for every one of those. There's copy, but again, we're not going to use any of those other ones, but they are there in Express. But for now, get. So get takes in 2 parameters, although it's only showing. Okay, well, in general, it takes in 2 parameters. The first is going to be the name of the route. So that'll be, we'll do, actually, I'm going to make this ping. /ping. So when I visit our localhost port 3001, which we'll set up in server.js, /ping, this is the route that's going to get invoked. The second thing it takes in is a function. And that function will take in 3 parameters, rec, res, and next. Rec is the actual request that was sent. And that includes everything we need, including the headers for the request, which we'll get into, the body of the request, all that fun stuff. Response is the response object that Express gives to us in advance, and it already has certain things on it. By default, it's got a response code of 200 unless we change it. By default, it's got an empty object for the body and an empty string for text. And then next is more used for middleware, but that tells Express that your function is done running. And normally in functions like this, we would have a return statement, but not in Express. Return is only going to be used if you want to exit the function for any reason and stop running and not run anything below it. But we're not actually going to be returning values in these functions. Instead, we're going to append the response object. So res.send. There's also res.json and JSONP, evidently. But when you do res.send, it will figure out what the type is. So if you send text, then the response object's text object is going to be updated. If you send a JSON, then it's going to send it in body, etc. So send pretty much does everything we need it to do. You can even send binary or byte arrays. That's what I was trying to think of. You can even send byte arrays, and that would be things like images. Express isn't as good at sending whole images, but it is something that you can do. It's going to be slow though. But we'll just send back Pong. And we can also append the status in this res object too, and these can be chained. So if we want the status for some reason to be 500 because something failed, or 403 because it's not an allowed operation, we can do it with .status. And in the parentheses, it's going to be whatever the code is. And there's a website that I'll share with you now that is something I still use for telling me what status codes mean. So 100 continue, 200 is okay, that's the most common. There's 403 forbidden, 405 not allowed, etc. So if you need a reference, this is what I use. So I'll post that in the channel as well. But for the most part, we're just going to be sending 200s. And like I said, the response object already by default has a response code of a status code of 200. So we don't even need to do this. The fact that we don't use .status, it's already going to be a 200. So that's all we need to get started. And then in server, we're going to import, oh, and I have to do this, module.exports equals app. So we need to export the app that we just created and set up endpoints for. And in server, we're going to import it. So const app equals require app. And Express doesn't care what port we're listening to. Usually I define it near the top of the file. So const port. And I usually like to use 3001 because your React projects, the NPX free React app, it will listen to 3000. So I just do 3001. App.listen. Not I gotta look up app.listen again. So app.listen, it'll take a callback function once the app begins listening and successfully bound to the port. It'll run this function. And usually I just have a console log that says app is running. And the second argument, I think, just make sure. The first argument is port. The second argument is the host name, which I don't typically use. And the callback is what runs once the server is up and running. So I'll just do this real quick. So you can see one of the ways, you don't have to use every one of those. There we go. We don't have to give it a host name or a backlog. We could just give it the port number and the callback. This is one of its overloads. So when the app is listening, I'll just do this console log app listening on ports and feed it the port. So we should be able to start up our app, hit the ping endpoint, and we should get back Pong. So we can open up Postman after running the app, of course, which I forgot what. Oh, one more thing we need to do. We didn't set up a start script. So I usually have two scripts. One of them's for testing, not for testing, for dev, and one for prod. But for our purposes, we don't need two different scripts right now. So we'll just set it to dev, and that will be node server.js. So I'll start server. It will require app. And whenever you do an import, it actually runs the file. So that will create a React app and then export it back to server, and then it will listen. npm run dev. And we see app listening on port 3001. So in Postman, we can go to localhost 3001/ping. And we see the word Pong. So are there any questions? Is everyone able to get to this? All right, I see nothing in the chat. I'm hearing no voices. So whenever we're creating our full endpoints, obviously we don't want all of the code in here, right? So if we have functions that'll do stuff like updating the database or literally anything else, we could have this syntax here, which where we define the functions fully in our app page, or we can have different files for our functions and import them. Because this is an anonymous function, whereas we can give it a variable as well in order to make this work. So I'm going to create a new file and I'll just call it ping. Ping.js. Const ping equals res or sorry, rec res next. And it'll just do the same thing, res.send Pong. Module.exports equals ping. And we don't need to import anything in order to make it work because we're already given everything we need as far as Express goes in these first three. And I also forgot next. is something we can use. Well, we don't really need to use because this is what's called a terminal endpoint. And once we start talking about middleware, I'll go more into that. But usually these things end with next being invoked. Next is the function that lets Express know that this is done running. You can also pass in error objects to next, which will tell Express to send back a 500 and whatever the message in the error is going to end up in Postman or wherever this is getting called from. Generally, though, I don't like to do that because if you just have a blanket error handler that just sends back whatever error is thrown, then you can expose things about your API that you may not want people to know, such as what it's running on. The error objects could have a stack trace on them that'll make it to Postman that'll tell what line of code went wrong, which gives hackers information that you don't want to give them. So that's just something I like to avoid, but I still use the next function in general for just for completeness, honestly, and also so I can assign middlewares that may run after these functions, whatever functions I write. So now we can start talking about middleware. So there's one specific piece of middleware that you're definitely going to need, at least in a development environment. There is something called CORS, C-O-R-S, that is a security feature of browsers that are worth having anyway, like Chrome and Firefox. CORS is a protection against something called cross-site scripting attacks. And what that means for us is if we don't have CORS enabled for our API, then we can't send a request from a web page hosted on a different URL to our server. And a different URL even includes 3001 or the port number rather. So if I have a React UI page that's running on port 3000, it sends a request to my API, which is on 3001. CORS will treat that as two different URLs and it won't allow the request to happen. So I'll demonstrate that later on with React app. But for now, we're going to download another dependency it's just called CORS. So npm I CORS, C-O-R-S. CORS npm. So what this middleware allows us to do is to, well, if we just invoke CORS and use app.use in order to set up the middleware, it'll enable all CORS requests. So our page that's hosted on port 3000 can talk to our server on 3001. Typically, you only want this enabled in a development environment because this, opens up some security issues. But once you're in a production environment where ideally your UI and API are hosted on the same website, you'll no longer need CORS. So you'll want some way to differentiate what environment you're running in, whether it's going to be in dev or in prod, which is something that we would use a environment variable for. But for now, we're not going to use it. We're just going to throw CORS in. So that should already be downloaded. It is in the package JSON. So in app.js, we can import CORS. And we'll use app.use CORS and invoke this function, which will create another function, which is kind of confusing. But what this does is every time you set up a middleware, or whenever you set up a middleware, every time a request is made to our Express app, this will modify the headers to enable CORS in that request, and then it'll move it on to our whatever endpoint it is we're setting it to. So we'll create a custom middleware real quick so we can see that in action. App.use. Regress next. And this could be something like a logging middleware. So if you want to log in particular, all requests that come into your Express app, we can either set the logger up, and we'll just use console log for this instead of saving to a database, but you would have to set a log to happen on every single endpoint manually, which is tedious and annoying, or we can use the middleware to have whatever logging functionality we want run before each and every request that's made. So that's what a middleware function will do. So this middleware will simply log hello for now. So when I call ping the next time I run this app, I should see the console log hello. And when I make another endpoint, any other endpoint, it should run this middleware first as well. And also, because this is a middleware, it's important to let Express know that the middleware is done running and to move on to the next function. So I'll run it and I'll move this off to the side so we can see it. I'll run ping again, and when I click send, watch the console. So it runs hello, or it console logs hello, and then it moves on to whatever endpoint we're actually hitting. So that's a middleware function. And of course, if I look at the headers, you know what? Maybe it's in the request headers. Oh, you know what? Yeah, those headers are actually created by Chrome. Postman doesn't create those headers, so it doesn't matter. But when we send a course request, it should be network. Where is it? Yeah, origin. So the host is API github.com and the origin is npm.js. The origin is the page that you're on, npm.js.com, where the request was first sent. And the host is sent to api.github.com for this particular request. This is a cross-site request. In fact, you could see it right here. Fetch site, cross-site, fetch mode is course, etc. And api.github.com is set up to allow cross things using course. So if I look at the response headers, I should see stuff related to course in here that says it's allowed. And that tells Chrome to go ahead and allow the referrer policy. That tells Chrome to go ahead and allow the request to happen. So origin, when cross-site origin strict, that's not the one I want. I actually don't see the specific one I'm thinking of here, but that's fine. You get the idea. If api.github.com was not using the course middleware, assuming it's running JavaScript, then it would stop this request in its tracks. So that's what we did there. And I'll demonstrate that later. Are there any questions so far? Course is kind of confusing, and there's a really good YouTube video that I'm going to send you after the class is done so you can see what course is, how it works, and what problems that poses for us. No questions? All right. So now we can get into nested routing. So nested routing allows us to create a set of routes that have a common route prior to them. So what I mean by that is npmjs.com/package/course. So course is the terminal endpoint in this particular GET request. Package is a folder above that, basically. So it's easy to think of these routes as folders. There's the packages route, or package route rather, and there's, God knows how many packages, over 1 million. It's npm. That if we're making an Express server out of this, then we would have a route called package, and define the route with the word package as well. So in order to do that, we can create a new folder and we'll just call it packages. And a new file, routes.js. So when we're creating a route folder, we would want to create another Express app. So const express equals require express const app, or I'm going to name this routes, or router actually, equals express invoke. So instead of app, I have router. There's not really a difference between these files, routes and app, because I'm creating more routes using Express here, and then I'm going to attach it to app. So I'll just create a couple of new endpoints. So app.get, not app, that's not what I wanted. Router.get, and we'll name this one something, and give it a function res next, and have it just return the word something. So res.send something, and module.exports equals router. So now we have our nested route set up, and we can attach it to app. So const package router equals require packages routes. You could also name this index, it doesn't really matter. I usually like to stick to routes. But now we have the package router, and we can do app.use. And the first thing I can set up is the route name, so packages or package. And I won't want the slash at the end. And I'll give it the package router. So this usually takes me a few tries, so it may not work the first time. But when I start the app up again, and we don't have hot reloading unless we set it up, which there's actually a package for that. That'll be the next thing I do. But we can visit the package endpoint slash something, and we should get back the word something. There we go. Now, one common pitfall with this approach is how you set the routes up. So notice I have to put a slash in here. If I don't have this slash and I restart the app, then I wouldn't be able to have the slash there. Although this wouldn't work because it's looking for port 3001 package at this point. So the slash has to be there. And Express is kind of stupid. So we have to explicitly tell it like there's a slash here. And where that runs into issues is if I were to take this slash away, I would have to take the slash away here as well. So if I restart the, and this is probably not even going to work, but if I restart the app, it's going to say error, doesn't know what that is. So we have to explicitly put the slashes there. But the weird thing is if I put the slash at the end of package and I restarted the app, I'll put the slash back here. Hang on. Huh. All right, that used to work. I guess it doesn't anymore, but we do have to have the slashes there so that Express knows, because we could have a sub route in here as well, which I'll get into in a minute. But you can also see that our middleware was firing off when I did that. Even this route is subject to the middleware. But if I wanted the middleware to a middleware to only run when a route in when a route inside of package is running, then I can just set it up to this route. And the .use won't affect any of the other endpoints up here. App.use, keep doing that. Router.use. And you don't technically have to give it rec, res, and next if you're not using them, but I just do that out of habit. Console log package. So when I hit the package endpoint, watch the console log, it's going to print hello and package. But if I go back to the ping endpoint, it only console logs hello at the top level. Now it was hanging for a reason. So package slash something. That middleware function is kind of just running forever. Express has no idea that it's done running. And that is because I forgot to put next at the end of this to let Express know that this was done running. So when I run it again, I should get something back again. So anyone have any questions on middlewares or routing? Take that as a no. So what was I going to do next? So I'm going to get rid of these console logs. And I'm also going to get rid of this package router because we no longer really need this. So now let's dive into the request object, and we'll just use the ping endpoint. So if I console log the entire request object, there's going to be a lot to look into. These are, you know what? So I don't have to keep doing this. We're going to npmi something called nodemon. npmi, excuse me, nodemon, nodemon. And what that is a that's an npm package that will do hot reloading for us. Whenever the code changes, it'll automatically stop the app and then restart it with the new code. In order to use it, oh, and you know what? I forgot. You need dash. I already have it globally installed, I think, but I'll run this again. You need a -G because nodemon is a command line tool, so it has to be globally installed. So in our dev script, we can replace node with nodemon. And when I run it, oh, why? Because I'm importing something that doesn't exist. So we could see as soon as I saved that file, it's since that I changed something, it loaded up the brand new code and it's listening on port 3001 again. Ping. So I'm console logging the entire request object, which is kind of a lot. All the underlying stuff is stuff that we shouldn't concern ourselves with. There's no such thing as private in JavaScript. So this is all stuff that Express is using that we should not mess with. But all the stuff that doesn't start with an underline is stuff that we are free to use. Again, there's a lot going on here, but we can see there's a lot of information like the user agent. In fact, this is headers. So user agent is literally the app that the user is using to access this endpoint. In this case, it's Postman, except it just accepts every kind of file type. Postman token, don't honestly know what that is, doesn't matter. This is our host. It's going to 3001, and there is no origin because we're not really on a website with Postman, except encoding. So we could send back gzips, deflate, br, and the connection is keep alive, which this doesn't really matter for us because this is, what's the word? I'm going to remember this word once class is over, but there's a paradigm that we're working with that HTTP in general with get, post, put, etc. works with. The name is escaping me, but basically it means that there's no session that's created. The connection isn't kept alive until the user's done with it. That's known as a session. In Express, we're creating, what is that word? But we're creating momentary connections just as long as the endpoint is being hit, and when it's returned, then it drops any record that it ever happened, unless we log it, of course. And CRUD, CRUD, is not necessarily what I'm thinking of, but it's related to it if you're familiar with it. It doesn't keep a connection alive, but each request and each response will usually have some kind of state inside. And that's generally what it works off of, instead of creating a session where you have a session token and all that fun stuff. Gonna remember the word later, but right now it's not coming to me. But we can see what URL was hit, the method that was hit, so we can use this for our logging purposes, for that middleware logger that we had that I deleted. There is also, oh, this is in alphabetical order, I think. So body will probably be, well, it doesn't matter. So we can get all kinds of stuff from the request. What we're interested in is going to be rec.body and rec.query. So what a body is, when we're sending a post request in particular, we're usually sending a body along with it. And typically that's going to be a JSON object. When we're sending a GET request, a lot of the time, if you've ever seen URLs like this, where there's a question mark and some variable name, var equals value, and it's separated by ands, that's called a query, a URL query. So that's something that's built into the URL itself, and that's commonly used with GET requests, mostly because GET is, for the most part, used for website URLs like this one. So that's what we can use to convey data to the server. So let's play with those. There's something you need to do first, but I'll show you what happens when you make a request to ping and you do rec.query. Even though we're sending a query, nothing's actually going to get sent through. var equals value. I think I'm still, yeah. Anyway, this is going to come up. Oh, right. Never mind. It's body that I'm thinking of. So query is already going to be good to go, but body is something that you have to do something real quick. You have to use a middleware function in order to access the body. Something else. In Postman, it doesn't do the same thing that VS Code does. You have to use double quotes. Otherwise, it gets mad. You have to put the keys in quotes as well. And your last element in an object or an array cannot have a comma. So Postman's a little bit more stingy with the JSON, or yeah, with the JSON. So if I try to console log, rec.body, I'm going to get undefined. That's what I thought would happen with query 2, but I guess it doesn't need that middleware function. But in order to remedy that, we can use a middleware function that will bring the request body into the actual request, because Express doesn't by default give us the request body, because technically that's sent in a different packet, a different set of packets. So app.use express.json. In previous years of this class, you may have seen me bring in body parser and then use body parser.json instead, but Express has this built in as a version 4. So if I were to make this request again, I should see this request body console logged. Yep, there it is. So I'm going to set up a post because you can send a request body in GET, but it's typically not done. Whenever you're sending information via GET request, it's usually going to be in query like we had before. So when I sent rec.query, var equals value, and var equals value 2, this may overwrite it, I'm pretty sure. Okay, so if so it's perfectly legal in a query to have the same exact key sent twice. So when that happens, you'll instead get an array of values attached to that key in the query object that Express builds for us. But otherwise, it'll just be a singular value. And like I said, you can add There's not really a hard limit in Postman, at least in Chrome and Firefox it is, but it's so long it doesn't matter. But there's a limit to how many variables you can attach in a query, and that's pretty much limited to the max length of the URL, which is pretty long. It's like 40,000 characters or something absurd. So you never have to worry about running into that limit. And you can send a whole JSON body basically in the URL itself, but then the URL is going to look disgusting. You'd rather send that in a body. And again, Express doesn't really care which one you use, because Express itself, to my knowledge, doesn't have a URL limit. And if it does, I've never run into it. But if you've got a more complex thing going on, excuse me, it's better to just send it in body. So now we can make a quick little post request. Wrong button. No. App.post. Rec.body, yeah. So const request equals rec.body. Well, typically I will set values directly from rec.body. So if I'm sending a username and a password, for instance, is a terrible idea, but username equals rec.body.username. Password equals rec.body.password. I'll usually do that. However, that is kind of dangerous because one of these can end up undefined if the body or the query doesn't include username or password in there. So you have to have built-in protections for that. And you'll have to code out a value checking system to make sure that username and password are in fact supplied. So that gets into code separation. When we were building out our React UIs, there was the concept of a controller and a component. The controller handled all the state, it handled all the side effects, and the component was just the dumb component that took whatever values you gave it and it displayed them in some way, right? The same kind of pattern can exist, it should exist in an Express app. So there's a concept of controllers and services. Naming may vary depending on the app, but that's how they should generally be separated. And what I'm writing out here is the controller. The controller handles the rec, rest, and next. It does, rest.sends and statuses and all that fun stuff. And the service only cares about the parameters that were given. So we can make a new folder called services and a new file, and I'll just call this login service.js. So const login service equals, and I'll just take in those two values, username and password. And I'll have it send back data to the controller using the return. So if username does not equal Mawine, it will return user not found. And if the password does not equal 1234, it will return password incorrect. Otherwise, it will return hello. And module.exports equals login service. So I'm making a service here. And like I said, this isn't concerned with the request, the response, or next. It's only concerned with the actual parameters in the body that are given. That way, you don't have to do any value checks, making sure that username and password are good values, they're strings, all that fun stuff. That's something that the controller is going to handle. So if we go back to the controller, which is in app.js, this should also be in its own file as well, but I'm not super concerned about that. I'm going to import login service equals require services / login service. So here is where I'm going to do all of my checks. Make sure username and password are defined and they're strings. So if username or type of username equals string, type of password equals string, then it'll run the login service with the username and the password. And depending on the result, if result does not equal, actually, I'm going to do this. Const status equals result equals hello 200 or 403. So if the result of login service is hello, then it's going to return a 200 status code. Otherwise, it's going to be a 403. Like I said, login service should not be concerned about the status code or anything like that. It should only be concerned with the actual data that was given, and it should return, whatever it's going to return. So what I'm going to have this do is response dot status dot send result. And I'm going to put in a return statement so that if this login service runs, it'll exit the function. Otherwise, it'll do rest.status 500 and result username or password, not a string, or it doesn't exist. It doesn't really matter what I type here. As long as it's verbose and it tells the user what the problem is. So the reason I have this return statement in here is because rest.status.send, this does not act as a return. If I don't have this return in here, in fact, I'll take it out so you can see what happens, then you're going to get a weird error. Although this will send back hello or whatever it's going to send back, it will also attempt to send this afterwards. And Express is going to stop that in its tracks, and you're going to get an error, but the user is not going to see that. So in the body, I'll type in username, wine, password, 1, 2, 3. That is the wrong endpoint. I'll just rename that to login. I'm gonna leave this as get for now, just so you can see. Express treats them as completely different endpoints. If get and post is set in our route declarations, then it's going to treat them as two different routes, depending on which protocol we tell it to use. In this case, I have it as an app.post. I think, yes, I do. Send. So password incorrect. Now we can see here headers sent. Cannot set headers after they are sent to the client. That's because we ran this line of code here and then immediately after ran this line. That's why we need the return. So that we don't get this error. Send. And it just sends password incorrect. We did not get that error. And if one of these is an improper format or type, then we get the status code of 500 here and the message that we typed out in that case. Does everyone track what I'm saying so far? Sounds good. So, what else am I missing? So middleware. So maybe there's middleware that we only want to run for specific routes, not all of them. And we can use the nested routing that we played with before, or we can explicitly tell Express that we want certain middlewares to run. So I'm going to create a quick middleware function just in line. Const my middleware equals yes, next. So log ran middleware and next. So maybe I only want this specific middleware to run on the login endpoint, or how about the ping endpoint, but not login. I wouldn't use app.use, express JSON like we had with our previous middleware, because that'll apply it to all routes. Instead, we can just add it in between the route declaration and the terminal endpoint here. My middleware will run in between them, and this can act in a variety of different ways. We can have it just simply log stuff. We can have it bounce a request if something about it isn't right, such as authentication. That's what this is most commonly used for. It could check for tokens if the user logged in and they were given a token. REST, that's what I wanted to think of earlier. So REST, I forgot what it stands for, but REST is the concept that state is carried in each request and no session is created. REST. And let me look up what that stands for. REST. So representational state transfer. So state, which we'll get into when we start talking about databases a little bit more, but state is what you want the server to work with. So state would include things like, who the user is, what they're requesting specifically, what their token is if they're logged in, and really for authentication, when you log into a website, typically you're given a token that your browser will save in a cookie. In fact, Facebook does this. When you log into Facebook, you typically only have to log in once every 6 months or even permanently. You're just logged in always. Your browser has a cookie saved, with a token in it. And every time you make a request to Facebook, whether you're creating a new post in Facebook or Instagram or wherever, that request that you're sending will include a token. So that would be an example of representational state transfer. It's already got your login information. Facebook just has to validate the token to make sure you are who you're saying you are. You're allowed to do what you're trying to do, all that fun stuff. And then it'll do whatever it is you're trying to do after it validates that. So there's Facebook isn't written in Node to my knowledge, but what they're doing on the back end is a middleware. Every single one of their endpoints probably has a middleware that's checking the token off the request, making sure that it's valid. It's probably calling another service that they have somewhere to validate that token. And then using the next keyword, it's going to allow the function to continue. But for now, when I hit the ping endpoint, I should see ran middleware. When I hit the login endpoint, I should not see it because we haven't bound the middleware to it. So I'll just run that for the ping endpoint. Well, here's the login endpoint. I don't see it. And now I see it, ran middleware. And I don't know what's going on here. Oh, that might be the query. Yeah. So query, if you don't supply one, it'll be an empty object. So this middleware, like I said, we can use this to kick back requests or allow them to go through. So we're going to make a token. It's just going to be like 4321 or something. So const token equals rec.body.token. And we're going to set this up with ping, even though it's a get. We're going to send it a body with token in it. And we can do if token equals 4321. It'll allow the chain to continue. Otherwise, and we'll just have a return statement for simplicity. Otherwise, res.send 403, status .403.send not allowed. So when I hit the ping endpoint next time, I should get a status 403 and not allowed. Not allowed. But if I add that token in there, 4321. Did I make that a string? I think I did. Yes, I did. When I send it again, it should just go through and send back Pong. So this could be a bouncer for checking if a user is authorized to do a thing. And it can also do things like, so a middleware function can do literally anything that a terminal endpoint can do. It can do a rest.status.send without allowing the next function in the chain to go through. It can take the username of the request after it authenticates the token. It can check what type of permissions that the user has. And if it doesn't have that permission, then not allow the request to go through. So I'm going to make a new endpoint, app.get secret information. And also, instead of camel case, I'm going to use snake case for URLs. URLs are generally in snake case. If you were to do secret information, the uppercase, because URLs aren't case sensitive, so that uppercase I won't matter. So you'd rather use snake case so that it's more human readable. But I'm going to have a middleware that will check permissions, and I'll just use my middleware again. Middleware. Actually, I'm going to create a new one because there's something really cool that I can do. Rec res next and rest.send nuclear launch codes. So we want this endpoint protected, but maybe we have several different kinds of users and only certain types of users can reach this endpoint. We can define that in a middleware as well. However, the middleware would have to be set up to specifically check what type of user this person is. So I'll just have a map that'll create user types. And the keys will be the usernames. So Mawine, and I'll make myself an admin. And Nico, I'll make him a what would be below admin? User. I'll make him a user. So it can check the user type, whether it's an admin or a user, and will allow them or not allow them depending on what their user type is. So I can get rid of this. We're not checking token anymore. So if const user equals rec.body.user and const user type equals user types user. So we're getting what type of user they are from this map. Again, this would obviously be in a database, but we don't have one to work with yet. So we're just hard coding it, but we would get the user type. And if the user type matches an allowed type in this middleware, then it would allow the request to go through. But we would have to make this middleware function for each, admin and user, depending on what type of user we want allowed to see secret information, right? So instead, we can have this middleware return a function based on what user types we want allowed in this endpoint. So this would no longer be a middleware itself. It would be a generator to create a middleware. So instead, we can have allowed users. And allowed users is going to end up being an array of the users that will allow. So return rec res next. And in this function, it would just do if allowed users dot includes user type next and return. Otherwise, rest dot status 403 dot send not allowed. So this might be a confusing concept, but when I trigger the middleware in each of my routes, it'll create a new function that will check what the type is based on what the type is up here, if that makes sense. So my middleware, and in this middleware, I want only admins allowed or admin allowed. Rec is not defined. Oh, probably need this up here. There we go. In fact, I could have user types in here as well, but basically we're creating a function that returns an actual middleware function just based on what the allowed users happens to be. So we can have only admins allowed here, and we can have only users admins allowed in this endpoint. There we go. So if I go into ping, my username is Mawine, that will show up as an admin, and I'll get rid of this stuff. It will send back Pong. Ooh. Comma. It will send back not allowed. Interesting. Why did that happen? Let's try this again. Undefined. Why? Why am I undefined? Oh, because I set it to user rather than username, like what the request has. So one more time, it'll send back Pong. And if I change this to Nico, it'll also send back Pong because he's allowed. If I send in any other username, it won't be in that array. It'll send back not allowed. Now, if I hit secret information with Nico's username, it'll send back not allowed. When I send in my own username, nuclear launch codes. So is everybody tracking? Does this make sense? Basically, this is a middleware generator, and I made it more adaptable by giving it a list of the allowed users so that I don't have to create separate middlewares to establish that an admin's allowed only or a user and admin's allowed. I just dynamically created the middleware function to return a express step function that will check if allowed users includes the user's type. Crickets. All right, so everyone completely understands what's happening here. All right, so Express, like I said, super lightweight, super easy, and fast to spin something up. Pretty much that's it. As far as Express goes, I'll copy this project and submit it to the Slack. And next time we're going to start talking, well, Nico may have some more stuff to talk about with the UI, but after that, we are going to start messing with databases. So we're going to spin up a Mongo database, which is completely free to do. It's a hosted database. We're going to see how to grab credentials for the database, how to connect it, which we would typically do inside of server, so that it connects to the database before it starts listening. And we're going to start talking about Mongo itself, how the queries are written up. Because if you've ever used SQL, this is going to be different. Mongo is a NoSQL database. It's actually a document database. So its primary purpose is to save JSON blobs. So it's super easy to work with as far as JavaScript goes. We're going to use a framework called Mongoose, which is there's an acronym for this too, but I forget what it's called, but it's basically a database manager. If you've ever worked with SQL, you know that you have to stand up the database first. You have to create the table schema. You have to do all that stuff. Whereas with Mongoose and with Mongo in particular, you are allowed to come up with your schema in code. In fact, Mongo doesn't exactly have a schema because it's just JSON blobs. But Mongoose allows you to assign a schema, but it also allows you to change that schema just in code without having to touch the database at all. Mongoose will just tell the database this is what our new schema is for any new documents, and that's it. It takes care of a lot of stuff for us, which is awesome. And Mongoose also lets you set, and when I say schema, I mean like what the table looks like. So think of an employee table. An employee would have a first name. No, that's not what I wanted. First name, a last name, job title, salary, etc. And Mongoose also allows you to set types to to these keys. So first and last name, that would be and job title would be a string, salary would be a number, and then you can have optional things such as bonus, because not everyone gets a bonus, things like that. And Mongoose lets you get really granular with this stuff. You can even define object or nested object schemas inside of the individual key names, which something like Postgres allows you to do too, but it's a lot more messy. The only drawback, I mean, there's quite a few drawbacks. It really depends on the app you're building. But the major drawback with Mongo is that it is not relational, at least not by design. All of these documents exist and they typically don't talk to each other. You want all of the data in the document that you would need, which you can make it relational, but you would have to code out the relations, and it's not as safe as something like Postgres, which wouldn't allow you to create a record that has a relation to something that doesn't exist. It wouldn't let you do that, but Mongo would. So you got to be careful with that kind of stuff when you design the database. And also, Mongo isn't for every app. It depends. If you've got a lot of data that is inherently relational, and meaning, well, that's hard to explain without getting into database theories, but if you have a data set that's meant to be relational, then Mongo may not be the app to use, but it's the easiest one to get started with JavaScript. And JavaScript also has drivers for things like Postgres. But in this class, we're not going to talk about Postgres, but if we've got extra time, maybe we can. Yeah, that's all I got for today, unless you have any other questions on how any of this worked. Was everyone able to make this happen on their end? Give me something. Yes, no?
No.
You weren't able to make it happen?
Sorry, I was able to make it happen.
Oh, okay, you just don't have any questions. Cool. All right, and I'm hearing crickets from everyone else, so I assume you understand this. And if I told you to do this exact same thing next week, you'd be able to do it, right?
Depends on how much I forget by next week.
Right on. All right, well, that's all I got. If you got any questions throughout the week, feel free to ping me, Nico, or Richa. And yeah, that's it. See you next week.
Bye.
See you.